Welcome to homework.
Okay, we need the structural isomers of n-pentyne. And with no number included, we would assume that this is our original molecule would just be linear 5-carbon chain with a triple bond between carbons 1 and 2. 1, 2, 3, 4, 5. Now note that we know that this contains 5 carbons, C5, and because it contains 2 double bonds, and we know the formula for degrees of unsaturation, that this should contain 5 times 2 plus 2, and then minus 2 for each double bond number of hydrogens. That's 10 plus 2 equals 12, minus 2 equals 10, minus 2 equals 8. C5H8. So how many structural isomers are there which have the formula C5H8, or a degree of unsaturation equals 2, right? So that would be any structure which contains 2 rings, if that's possible, or 2 double bonds. Well, let's look at the structures that contain 2 double bonds by way of a triple bond. Well, we have n-pentyne itself, 1 n-pentyne, but we can imagine 2 n-pentyne, for example. One, 2, 3, 4, 5 carbon chain. And would it work to do 3 n-pentyne? No, because we get the same exact formula as 2 n-pentyne if we count from the proper side of the molecule. What about 2 sets of double bonds? We could imagine a 5-carbon chain in which double bonds are on either end, such as this, or we have a double bond on one side and then a conjugated double bond, perhaps the same molecule but the stereoisomer of it, like so. And we could consider stereoisomers of this molecule, but we'll notice that we always have hydrogen on either side, or 2 hydrogens on either side, meaning that's not quite possible. So here are our 2 possibilities which contain double bonds. Now recall that ring structures also increase the degree of unsaturation. So if we had, for example, a 5-membered ring which contained a double bond, this would have a degree of unsaturation of 2. Or a 4-membered ring which contained a 4th carbon as well as a double bond, or as a methylene group, or a 3-carbon ring, and an additional 2-carbon chain which contained a double bond, and finally we cannot put a double bond here because the geometry wouldn't work, and there's no way to do a structure with 2 rings that I'm aware of. This would be 1, 2, 6 carbons. If we attempt to remove a carbon by doing a bridge system such as this is far too unstable. So these are the reasonable structural isomers of n-pentyne.